Hello everyone, welcome to my tutorial on Java. Today's tutorial I'm going to continue with my discussion on the collection framework, and specifically today I'm going to talk about list. A list is a part of collection, and this is also very important in terms of interview perspective because you may hear from the interviewer a lot of questions on lists. So what is a list? A list is an ordered collection, sometimes called a sequence, and lists may contain duplicates. So that means we can understand that list can hold a number of collections, and the collections will be sequential and they can hold the duplicate elements. And in our example, when we're going to do in the Eclipse, we'll see like how it works. So lists provides the following functionalities. It provides the positional access. That means we know that the collection is the job of the collection is to manipulate the objects within the collection. So in here we manipulate elements based on their numerical position in the list. So basically we can get a list based on the index of that element in the collection. That is what we're saying here, that the positional access. Then we can do search things. So searches for a specified object in the list returns its numerical position, and search methods include index of and last index of, and we'll get to know about those. We can do the iteration thing. So in order to manipulate the collection or manipulate the list, we need to iterate, like we need to move from one item to the other, and we can do the iteration. So it extends the iterator semantics to take advantage of the list sequential nature. The list iterator method provides this behavior. And then we can also do the range view, that we can make a sublist of the list. Okay, so these are the features of list. So we now know the definition and we know the functionalities. Now let's go into the implementation thing. So list is an interface, but the implementation class is the array list, linked list, vector, and stack. So there are basically four type of implementations which are important: array list, linked list, vector, and stack. But we are going to talk about more with the array list and the linked list. The array list internally uses a dynamic array to store elements. Linked list internally uses a doubly linked list to store data. So the implementation here is different, although the basic nature, that means the sequential nature, is still the characteristic of both the array list and the linked list, but the implementation is different. So the array list is using the dynamic array to store elements, and the linked list internally uses a doubly linked list. And if you follow my tutorial, the algorithms in Java, you will be more clear on what we mean by the dynamic array and the linked list type. And then the manipulation with the array list is slow because it internally uses an array. A removal of an element requires shifting of the elements, but linked list doesn't need this shifting, and as such manipulation is faster. So this is a very important aspect that we need to know in terms of interview, because a lot of the time people ask that which one is faster, and we say that the linked list is faster because you just break the link and get a new link. But on the other hand, the array list is where you have to move the elements, so that is a little bit slower. Okay, and array list is faster for storing and accessing data, but linked list is better for manipulating data. So again, I'm saying that if you follow the tutorial on algorithms in Java, you'll be more clear on the implementation aspect of the list. Okay, so now let's get into the coding itself. I have already created this class, public class collections O2, and there you can see that I have created a list. There is a method, and the method is the create list, and then there is an add all, there is an insert list. These are all the methods that I have created. Okay, so now let's get into how we are going to create a list. So you can see that this is how we create a list. Student list. So this is just creating the reference. as we know that at this moment the reference is not pointing to anything. This is null, and at this point if you would like to access the student list, you will get a null pointer exception. But whenever you are doing the new array list, that's the implementation. So we are going to implement it using the array list, and we are using the student object here. So that means this list is going to contain the student object. So now here, once I have created the implementation thing, this is just a one line, and then I'm creating the new object. And if you go here, the student, here I have created a class that is the student with just two attributes, name and ID, and they are the getter and setter methods. Okay, so I am instantiating that one, student s1 equals new student. I am assigning the values to that, and then I have created a new student with s2 reference, and then I am adding the values, or I am adding these two objects to the student list. And in order to that, we have to just call the add method of the list. So this is coming automatically. Whenever we are using the list, we can use the add method to add any kind of collections. So now if we are going to use that in a separate method, let's say here, this is the main method which I'm going to execute right now. Okay, so and there I have created another student object which is student insert, and I'm creating the new student, and this is the insert.id is my, I'm assigning the value to the ID, and then I'm assigning the value to the name, and then I am passing this one. Let me save it. I'm passing this value. This insert is basically an student object to insert list here. So this is my method which I'm going to execute. Now if you look at this method is list student list equals create list. So now here I could have done this in another line, like list student list, which is just creating the reference. Okay, and then student list equals create list. I could have done this. Okay, or I could have done this, that student list equals new array list. Okay, and then this array list, this student list is now empty, although the object is created. It's pointing to a new array list, but it doesn't have anything. Okay, so in order to have that, I could have then call this create list, okay, to populate my new list. Okay, so there are many different ways to do it. Okay, so it's up to you, like what you want. Now let me explain again here that I have created this list student list, and then I have invoked this method here, create list. Okay, so if you go here, the method, this is the first thing I showed you. We have created two student objects, and then we have added those two student objects in my list, and then I'm returning that to my student list. So now if I am going to run it, let's see what happens. And you can see that in my list there are two objects. Okay, so the first two are created from this create list. Okay, and the third one I have provided from my main method. I have created a new object, new student object. I passed that to this method, and I have just added the new student object. So the main thing here that you can add any object to the list using the add method of the list. Okay, so now let's move on to the add all method. So the list also provides another method which is very helpful, which is called the add all method. So now let's see how it works. If you come here, you can see that I have got the old list, okay, which I'm getting the student A and student B from this method, and here I have created a new list, and then in the new list I have added the student number 3, and then so the new list now have one object which is S3, and then I'm adding all the students from this student list, okay, and then I'm going to print it. So now let's see if I'm going to run it. Sorry. And you can see that we are seeing that student name C, ID 3 and AB. So these two methods were added to the new list, and the new list actually printed all these three. So we have an add all method in the list that we can use to add all of the list. Okay, so now let's look at this method. What we are going to do here, get student. If we go here, I'm getting the list again from the list I created, and then I am trying to get the first student. Okay, so this is how we get. So the list has a method that is called the get, and with the get you have to pass on the positional parameter. Okay, so this is how it works. Some list dot get. Okay, so some list is the list that holds all the collections, and then you call on the get method, and then you pass on the positional parameter. Let's say we would like to get the first item, that is the get 0. Okay, because the index starts from 0. If we would like to get the second item, we would have said like 1. Okay, so the sum list dot get, and then you put the position parameter, and then you get the student. Okay, so now let's see. We are going to run it. And you can see that the first item is printed, student name A and student ID is 1. This is how we keep on manipulating our list. Now let's see what this method is doing. So this is a contents item, and we have added name list dot. So this is, we have created a new list, name list. Okay, and we are passing on the string parameters, and we have added two items. Okay, name list dot add A and name list dot B, and then we are trying to find out if this list contains the string B. Okay, so the list has another method that is the contains, and after the contains you pass on the parameter. So okay, so now if we are going to run this, and you can see the element exists true. Okay, so if we go here, okay, so you can see that the contains method is very useful in order to find if some item is in the list. Okay, so now let's move on to the next method, and here we are going to remove. So we know how to get an item, and we are seeing that how to remove an item. So again the same thing, we are getting the list from our old list, and then we are going to remove the first item. So this method we are invoking remove, and then we are passing on the positional parameter. Okay, and that is 0. We'd like to remove the first item. So now if we are going to run as Java application, and then you can see that the first item is removed and the list only contains the second item. Okay, and there is another important method in the list, which is the size. So we can, okay, let's go here, and you can see that I have again got the list item, and then we are going to try to print the size of the list. It should be printing 2. So if we are going to run this, it should print 2. So the size method is already in there in the list. You have to just invoke and it will print the size of the list. That means how many elements are there right now in the list that will be printed. Okay, so this is what we have seen. If you'd like to see that how I have printed the list, this is how I have printed. Okay, so this is the student list. Okay, so this reads like this: for student S, and look into the student list, and then we are going to print the s.name and s.id. This is something we covered in our iterable class in the last tutorial. Okay, there is another thing I would like to show you here. Let me bring it up here. So let's say you have a list, my list, okay, and you'd like to remove some item, and the contents are here that the student object. So let's say for I equals 0, I less than my list dot size, and then I plus plus. Okay, and then you have to actually get the student object out of it. Student S equals my list dot get I. Okay, so this means that you are iterating the list, and each time you iterate you get a new student object that is in the list. So in case of the first iteration, this is going to be 0 and you get the first list. Okay, and then if s dot id equals, let's say, 1, then my list dot remove s. So what it will do, it will just remove the item from the list. Okay, so that's all for today. Thank you very much.